So yesterday there was a bit of confusion with the finding matrices, and I was trying to, testing each point to see what happened. Then we use that in discovering the matrices. But that looks like a very difficult approach for some of you to be able to grasp what exactly does the matrix looks like. So if there was an IGCSE question today, for example, and I'm sure about maybe half of the class still will have to go through that old long method to be sure that this is indeed the matrix, or memorize all the matrices. So now, instead of doing that, I need us to just listen for about 5 to 10 minutes, and I think this would be an easy way to figuring out what matrix to use. And this doesn't take more than, say, 2 minutes, even in the exam room, for you to figure out whatever you need to figure out. So it's not going to be a waste of time, it's quite efficient, and you do not need to memorize. Does that make sense? So I just need you to be very attentive. Now, I'm going to start with the identity matrix again. Yesterday we agreed on one thing. If the identity matrix is your transformation matrix, what happens to the positions of those shapes?
It doesn't change.
It does not change. Okay? So we're going to start with that. So we're going to start with reflection again. The identity matrix is one. Okay. Do you agree this is the identity matrix? Yeah. Okay, there's a reason I'm doing this. For each column, it looks like this. Each column of the identity matrix looks like this. Is that not? Okay, I'm trying to give you a clue for you to remember what I've done. Now, we just demonstrated this jokingly in class, isn't it? What do we call that? Translation, right? We did a translation here to move these tables, right? Okay. What does this first part represent? And this second part? So, look at the column of the identity matrix as some coordinates of a point, of 2 points now. So this is your xy, this is your xy. Pretend that these are 2 points on the xy plane. Okay? So if we pretend these are 2 points on the xy plane, I think we don't need too much space. These black points, when x is 1, y is 0, will be here. Agree? Yeah. And the blue, when x is 0, y will be 1, will be here. Do you agree? Mm-hmm. So we are going to take each of these points one by one and go through this and see what this matrix changes to. And whatever it changes to is the transformation matrix you're looking for. So to start with, the first one, along x-axis. Now, this is your x-axis, right? If you reflect these 2 points along x-axis, what happens to the first one? Stays the same. Okay? It's going to stay the same. So this remains 1, 0. This looks like some of you know what you do. Yeah. The girls will understand. The boys will never understand what they do with that stuff. Anyway, what about the second point? If you reflect along this part, what happens to it? It comes here. Do you agree? So it comes to which point? 0, -1. So this does not change. 1, 0 doesn't change. But this changes to what? 0, -1. This is your transformation matrix for reflection along the x-axis. Does it change?
In the summary paper, you said it's 1, 1, 0.
1, 1?
It's 1, 0, 1 there. For the summary paper, you said
1, 0.
Oh, it's
1
wrong.
negative.
Your paper is wrong. You got it wrong here in your paper.
Yeah, I think I said, did anybody write what I wrote on the board?
Yesterday.
Did I say something about typographical error somewhere?
Yeah, you said.
Yeah.
Did we? I thought I asked some people to check.
checked it.
Oh, no, look at it. There's something is wrong. Look at that. We shouldn't have 1, 1. None of our matrix has 1, 0, 1, -1. This is what you have in that paper. I knew there was a typo in that paper. But none of the things we had yesterday look like this. Remember, everything looks like the identity matrix, but different arrangements. So none of them actually look like this. So this must be the typo I was looking for yesterday. Okay? So that's the first one. Quickly, please pay attention once again. So change that, and if you just change that to 0, I think we are good, right? So this is for the first one, reflecting along the x-axis. This doesn't change, but this 0, 1 changes. Okay? Now for the second, it says along the y-axis. Can we think of that here? Or do I draw another xy? Maybe I draw another xy axis. You don't need to draw it, of course. So the first point, I use the black and the blue once again. The first point, x is 1, y is 0. The second point, x is 0, y is 1. Please, I need your attention. Now, if you reflect along the y-axis, which of them remains the same, which of them change?
0, 1.
Remain the same.
This remains the same,
Yeah.
and this will change. To what?
To negative 1, 0.
So it changes to this point. Negative 1 and 0. So the transformation matrix for this, so the 1, 0 changes to what? Negative 1, 0. But the 0, 1 remains what? 0, 1. So this will be the transformation matrix for reflection along the y-axis. I think this is a much easier way for you to remember what to do. So even if you are lost in the exam room, just remember each of these columns, pick them as your xy coordinates. Why did I say that? Each column, remember your translation, we always use that as the xy coordinate. So use that as some kind of, it's like you're going somewhere and you need a landmark. Something to make you remember. Does it make sense now? Okay, so the third one. We want to reflect along y equals x. So remember there are 2 points and your line y equals x is this. Okay? So the first point here, 0, 1, and the other points, 1, 0. So raise your hand, I'm going to ask you a question. If you reflect along, because the first column is this black one. If you reflect along y equals x, what happens to this point? Raise your hand, I need a response now.
It switches with the other one.
What?
It,
Again?
1, 0 switches with 0, 1.
And this one, so they kind of interchange. So which means your identity matrix will have their columns interchange. And that will be what?
0, 1.
0, 1 here, 1, 0 here. Does it make sense? Kelly, are you listening to me or you're just doing your thing? Tell you to give me just a few minutes. You're troublesome. Fella. Okay? So now, reflecting along y equals negative x is this. And the 2 points are 1, 0. The other point is 0, 1. So what happens to them?
They both become negative.
They both what?
Become negative.
Can you understand? Do you understand what I'm doing here? So what happens here? Both come down.
Yeah.
So where does this black come?
0, negative 1.
0, negative 1. Here.
Negative 1, 0.
Then this comes to,
Negative 1, 0.
so this comes here, and this point will be x is negative 1, y 0. Can you see that?
Yeah.
So the transformation matrix will be, for 1, 0, it becomes 0, negative 1. For 0, 1, it becomes minus 1, 0. Does it make sense? That's all about the reflection. Okay? That's all about the reflection. Now let's look at rotation in a similar way. For rotation, so we still have 2 points. The first point is here. Second point, so the first point is 1, 0 again. And the second point, come on, is 0, 1. Okay. Rotate 90 degrees clockwise. You know what 90 degrees clockwise is, right? So where does this black point go to after 90 degrees? What?
0, negative 1.
0, negative 1. 0, negative 1, x is 0, y negative 1. Here. Okay? And where does this go to?
1, 0.
So this comes here, this comes here. Does it make sense?
Yeah.
So this is 0, negative 1. So the transformation matrix, so 1, 0 becomes 0, negative 1, 0, 1 becomes 1, 0. So that is reflection, rotation along 90-degree clockwise. For rotation 90-degree anti-clockwise, and enlargement is not really, yeah, I think that's quite easy. That was quite clear yesterday. But anyway, so this is your 1, 0, 1, 0, 1, 0. 0, 1, 0, 1, and 0, 1. Okay. Now, so this comes here now. It comes here now as 1, 0, and this comes here. So you know where the black moves to and where the blue moves to. This doesn't change. What is this? Okay, so this goes over there, and this comes here. So you can understand how we got that. Okay? I use the arrow to show their movements after the reflection. So similarly here, this comes here, and this comes here. So that makes it easier for us. Okay, so number 6 is 90-degree anti-clockwise. So anti-clockwise is this way, right? So where does the blue come to? It comes here, and the black one goes to. Can we see that? So the black one comes here. That's 0, 1, and the blue point comes to negative 1, 0. So the transformation matrix would be what? The first column?
0.
First column will be 0, 1, and the second column will be negative 1, 0. So for 7 is 180 degrees. So if you rotate this 180 degrees, where does it go?
Go somewhere.
Other side.
Yeah, which is.
Okay? So it comes here. Whether clockwise or anti-clockwise. If you go the other way, it still comes here. Then if you rotate the blue one, where does it come? Comes here, right? So where is this point?
0, negative 1.
0, negative 1. And where is this point? Negative 1, 0. So the transformation matrix, therefore, for the first column of 1, 0 is what? Negative 1, 0, right? And for the second column of 0, 1 will be what? 0, negative 1. So that's the transformation matrix. And for the enlargement, if you enlarge this by a scale factor of k, you enlarge this point by a scale factor of k, it's like a column vector, k times 1, 0. What's that?
K0.
K0. So it moves forward. You're enlarging this by a scale factor of k. So you're just moving it forward. Does it make sense now? So this is your K0 because it's enlargement. And when you enlarge this as well, because enlargement stretches everything, isn't it? So this becomes bigger along y-axis, this becomes bigger along x-axis. Does it make sense now? So this will be what? 0k. And that was clear already yesterday anyway, just to demonstrate it in this form as well. So if you enlarge that, we have that as 0k somewhere here. This is the scale factor of k. So this comes to this point, and the matrix transformation will be K0, 0k, like we said yesterday. Does this make sense? Is this better? A better way to understand and maybe bring them out even in exam. Okay, so you don't have to memorize these 8 matrices. All you have to do is remember how to flip. Remember, reflection will be in 4 different ways. Everything passes through the origin. Along x, along y equals x, along y equals negative x, for matrix transformation at this point. Any questions, please? No questions?
No.
All right, so we can continue from
Alex.
our worksheet from yesterday.
I just want to get the full screen.
Yes, please.
Do I stop it, Mr. Daniel?
If there are no questions, yes.
Definitely.
Which worksheet? So what do you want me to do? I don't have it right here. The only last one I have is for Trudy. Yes. You have a question? You may stop it if you.